Welcome to mates. This is our same Mangeya, the mates ego. Right. On this video, we are going to learn about tangents and normals. How to calculate the equation of a tangent using differentiation. Equation of a normal using differentiation. What is a tangent? What is a normal? That's what we are going to learn in this video. After watching, please like, share and subscribe to this nice powerful video. Watch out. Let's get started. What is a tangent? If I can have my drawing like this, for example, this one is a curve. I can label this one as a curve. Then a tangent is a line that meets the curve at only one point. That's called the tangent. Like if we can have this point here, then this line will be called a tangent because it's meeting the curve at only one point. Therefore, it's called the tangent. Then, what can you understand about this tangent? You can also look for my video. I have done another video on coordinate geometry. It's there on my YouTube channel at Lakson Mangeya. It will help you understand tangents, even normals, gradients of them. You'll be helped in that video. Right, tangent, a line meeting the curve at only one point. That's called the tangent. Then, what's the relationship between the two? The relationship is gradient of tangent and gradient of curve is the same at that point of meeting or intersection. That's what you have to understand. Then, we have also a normal. Normal is a line that is perpendicular to the tangent, like this, which means it meets the tangent at 90 degrees. This line will be called the normal line. Normal line because it meets the tangent at right angles at 90 degrees. Aha! Normal and tangent, they are perpendicular to each other. They meet at 90 degrees. Then, what do they have? What will be their relationship in this case? Let's say the equation of this one was y is equals m1x plus c1. Then equation of this one, tangent, was y is equals m2x plus c2, like this. Then you have to know that the product of the gradients is supposed to give you minus 1. Gradient of tangent times gradient of normal is equals to minus 1. That's the relationship between the two, which is m1 times m2 gradient of tangent is equals to minus 1. That's what simplifies their relationship. Is based on their gradients. Their product of the gradients gives us minus 1. Then done. Then going down, I've just used questions to make you understand better. I'll just use questions in this case. Question number 1. Calculate the gradient of the tangent to the curve y is equal to 3x squared minus 5x plus 2 at the point minus 2, 3. So this point is minus 2, then 3. What will be the gradient of the tangent to the curve at this point? What you do first is simple. You differentiate. There's also a video on differentiation. You can look for it. You can check it on my YouTube channel. Is there. Differentiating this one, let me rewrite the equation of the curve. Is y is equals to 3x squared minus 5x plus 2, like this. Then differentiating this one first. That's finding gradient, dy dx. Remember, dy dx is the gradient, that is of the curve, that is of the tangent at the point where they meet. In this case, x is equals to minus 2. So first you differentiate, then you put x minus 2 to find the gradient of the tangent at the point minus 2, 3. Dy dx, that's gradient. Dy dx is equals to, here you say 3 times, you bring down to the power x the power 2 minus 1 minus, then differentiating 5x you get 5. Remember, then differentiating the constant 2 you get 0. So there's 0, you don't write anything there. It will be equals to 3 times 2. 3 times 2 is what? It's 6. X the power 2 minus 1 is 1. So it will be minus 5 like this. Remember differentiation of minus 5x. This one, you say it's minus 5x to the power 0, x to the power 1. When there's no power, it's 1. So divide x based on this, it's minus 5 times, bring down 1, then x to the power 1 minus 1. It will be minus 5 x to the power 1 minus 1 is 0. Then minus 5 times x to the power 0 is 1. Minus 5 times 1 is 5. It's minus 5. So that's the minus 5 here. Just as a recap, right? For you to just remember. Right, then divide x is 6x minus 5. We want the gradient when x equals to minus 2. Because the point is minus 2, 3. So this one is for x, this one is for y. So when x is equals to minus 2, is equals to minus 2, dy over dx is equals to 6 times minus 2 minus 5, which is equals to 6 times minus 2 is minus 12 minus 5. Then you get minus 17. That will be your dy dx when x equals to minus 2. The point minus 2, 3. Next, question number 2. Find the coordinates of the points on the curve at which the gradient is minus 1. Gradient, we're now given the gradient. We're being asked to find the coordinates of the points where the gradient is actually minus 1. How can we find the coordinates of the point? Right, first thing, let me rewrite. It's y is equals to x cubed. That's the equation of the curve. Minus 7 over 2x squared plus x. Like this. Then what will be your dy dx first? That's the gradient is equals to. So you find gradient, then equate to minus 1. Because you are given that the gradient is minus 1. So you just equate to minus 1. Here we bring down 3x to the power 3 minus 1 minus 7 over 2 times, bring down 2 here, x to the power 2 minus 1 plus, here the power will be 1. So you bring down 1, x to the power 1 minus 1. That's how you differentiate. Then it will be x to the power x 3x to the power 3 minus 1 is 2 minus. Then on this one to simplify 2, then it will be minus 7x to the power 2 minus 1 is 1. You don't write the 1 here. Then plus x to the power 1 minus 1 is 0. X to the power 0 is 1. Then 1 times 1, this one is 1. Like this. Then we are given that the gradient at which the gradient is 1 here, it's minus 1. What do you do to find the coordinates? Coordinates, we have x and y. It's more like x and y here. These are called the coordinates. So we want the value of x and the value of y when the gradient is minus 1. Alright, how do you find it? You now equate, you are given that gradient dy dx is minus 1. So you say this dy dx 3x squared minus 7x plus 1 is equals to minus 1. Like this. Then you solve as a quadratic equation. 3x squared minus 7x plus 1. Then plus 1 is equals to 0. Take this one, put it on this side, so that the right side must always be 0. That's on quadratic equations. Simplifying this one, you get 3x squared minus 7x. Then 1 plus 1 is plus 2 is equals to 0. You factorize this one to get two values of x at the point where gradient is minus 1. This one you get plus 6x squared. Then what are the factors here? You get minus 6 and minus 1. These are the factors. Multiplying, they give you 6. Adding, they give you minus 7. So it's minus 6x and minus 1x. Replace those factors with the middle value. We replace the middle value with those factors. So it's minus 6x minus 1x, which is minus x. Then plus 2 is equals to 0. Check, I also have another video on solving quadratic expressions. Solving quadratic, how do you factorize? Factorization of quadratic expressions. You can check it, you can see how do you factorize. Then you take this and this, this and this. It will be, you factor out 3x here, x minus 2, minus factor out 1 here, x minus 2 is equals to 0. Then x minus 2, the same. You write x minus 2, then 3x minus 1 is equals to 0. 3x minus 1, these are the values which are outside the brackets. This one, 3x and minus 1. Then I write this one, you write the values also outside the brackets. So it will be like this. Then you find the values of x here. You say x, either x minus 2 is equal to 0 or 3x minus 1 is equal to 0. If we can simplify this, you get x is equal to 0 plus 2 is 2. Or x is equals to, then on this one, 3x minus 1 is equal to 0. First you take 1, you put it on this side. It will be 3x is equals to 0 plus 1 is equals to 1. Then you divide by 3, you get x is equals to 1 over 3. That will be your final answer. Then you have found the values of x. Now you have to find the corresponding values of y. You say when x is equals to 2, what will be y here? Y will be equals to, then you check here, use your original equation of the curve. It's y is equals to x cubed, which is 2 cubed minus 7 over 2. Then where there's x, you put 2 squared plus 2. Everywhere there's x, you just put 2. Then 2 cubed is 8 here, minus 2 squared here is 4. 4 divided by 2 is 2. 2 times 7 is 14. Then plus 2. 8 minus 14 plus 2. What do you get? X minus 14 plus 2. Can you use your calculator? X minus 14 is minus 6. Minus 6 plus 2, it will be minus 4. So it's supposed to be minus 4 here. That will be the first coordinate, x2 and y minus 4. That's the answer that is needed. Then you find another coordinate. When x is equals to 1/3, what will be y? You say when x is equals to 1/3, x is equals to 1 over 3, y is equals to 1 over 3 cubed minus 7 over 2 times 1 over 3 squared, then plus 1 over 3. Just substituting in your equation. Then y will be equal to 1 cubed here, simplifying is 1 over 3 cubed is 27. Let me simplify a bit. Then here 1 squared is 1, 3 squared is 9. So it will be 7 times 1, 7 over 2 times 3 is 2 times 9 is 18. Then plus 1 over 3. Like this. Then if you can simplify here, you get y is equals to 1 over 27. 1 over 27 minus 7 over 18. 7 over 18. 7 over 1/8 plus 1 over 3 plus 1 over 3. You get minus 1 over 54. Like this. So this will be another point. When x is equals to 1 over 3, what will be y? It's minus 1 over 54. So these are the two coordinates or points where the gradient is minus 1. So you have this one and this one. These two are the coordinates that you have to find in this case. Question number 3. Use differentiation to find the equation of the tangent at the point 2, 1 on the curve. So now want the equation of the tangent at the point 2, 1. We're finding initially the gradient. Now it's about the equation. Right. The same rule applies. It's a tangent here at the point 2, 1. What you have to know is that gradient of tangent and curve at that point is the same. It's equal. So just find dy dx using the curve equation. Then put x is equals to 2. Because the point 2, 1 means x 2 and y 1. Put x 2, find gradient, and you have a point. To find equation of a straight line, you just need 1 gradient and 2 points. The point is already given, it's already there, 2, 1. But gradient, we don't have it. We have to find gradient using the curve. Find dy dx using the curve, put x is equals to 2, then find gradient, use that gradient and the point 2, 1, find the equation of the tangent. That's what I'm going to do in this case. Right, first thing, you write y is equals to, this one will be x squared minus 3. First thing, put to the power half. Square root of x is the same as x to the power half. Then, working out this one, you find dy dx here is equals to, bring down half. Differentiation of this type, I have already explained it. There's a video on my YouTube channel. Then x squared minus 3. Then you subtract 1 to the power. Then multiply by the derivative of what is inside the brackets. X squared minus 3. You differentiate that one. You get 2x. Because x squared you bring 2. Then x to the power 2 minus 1. It will be 2x. Then simplifying this one. 2 and 2 cancel out. This 2 and this 2 cancel out. Then it will be x squared minus 3. Then half. Then you can put this x here. Then half minus 1 is minus half. Like this. Then you can simplify it to x over. Then this one, you can say x squared minus 3 to the power half. Applying the laws of indices. This one can be simplified to x over square root of x squared minus 3. That's x to the power half. Then now we say when x is equals to, you go up here, you want the gradient when x equals to 2 here. So find x2, put x2, then find dy over dx is equals to 2 over square root of 2 squared minus 3. Like this. Then after that, you can find here 2 over 2 squared is 4. 4 minus 3 here is 1. Square root of 1. What will be square root of 1? It's 1. It's 1. So it will be 2 over 1. Gradient will be equal to 2. So this one will give you 2. So we have now we have our gradient 2 and point 2, 1, which can be m on a curve. Because on the tangent. Tangent is a straight line. So to find the equation of a tangent, you say y is equals mx plus c. So m will be the gradient, which is 2 in this case. It will be y is equals to 2x plus c. Dy dx that we have found where x was equals to 2. Then to find c, use these coordinates 2 and 1. It means x is equals to 2 and y is equals to 1. Then put why there's y, you put 1. Where there's x, you put 2 to find your c. That's how you find the equation of a line. 1 is equals to 2 times 2 is 4 plus c. It will be 1 minus 4 is equals to c. 1 minus 4 is minus 3 is equals to c. Then you substitute. You substitute here on this one. On this one. It will be y is equals to 2x minus 3. So this one will be the equation of your tangent. We can say you are done. Right. Next, find the equation of the normal to the curve. These are now normals at the point where x is equals to 1. Equation of the normal to the curve at the point where x is equals to 1. So it will be like this. This one the curve, the tangent. Then normal will be perpendicular to the tangent. And x is equals to 1. You have to find out if x is 1, what will be y? So you substitute in your equation this one. Y is equals to x cubed plus x plus 1. So you put, where there is x, you put 1. 1 cubed plus 1. You get y is equals to 1 cubed is 1. 1 plus 1 is 3. So y will be 3 in this case. That's the point. So already we have a point. To find the equation of a line, we need point and gradient. Now you have a point. What is left is the gradient. How can you find the gradient? You find the gradient of the normal from the gradient of the curve. Curve and tangent are the same. So you find dy dx. After finding dy dx, you put x is equals to 1. Then after that, use the concept of normal and tangent. m1, m2 is equals to minus 1. So let's find dy dx first. Our equation, as you can see, let me rewrite it. It's y is equals to x cubed plus x plus 1. Then from this, let me find dy dx. Dy dx is, you bring down 3 here. then x to the power 3 minus 1 plus x to the power 1, you bring down 1 here, x to the power 1 minus 1. Then differentiating a constant 1, you get 0. So this one will be 0, you don't write anything. It will be 3 here, x to the power 3 minus 1 is 2 plus here, it's 1 times x to the power 1 minus 1. X to the power 1 minus 1. 1 minus 1 is 0. X to the power 0 is equals to 1. Any number raised to the power 0, the result is 1. So this one will be 1 times 1. It will be 1. That will be a divide x. Now 1 divide x when x equals to 1. So you say when x is equals to 1, dy over dx is equals to 3. You put where there is x, you put 1. 1 squared plus 1. It will be, simplifying this one squared is 1 times 3. 3 plus 1 is 4. So gradient is 4. Now we are left with this one, gradient of tangent. Please take note of tangent or curve. Tangent and curve have same gradient, but normal and tangent, they have this relationship. Their gradients, m1 gradient of normal times m2 gradient of curve is equals minus 1. Now you have gradient of tangent, gradient of normal and gradient of tangent. Multiplying them, they give you minus 1. So you can say 4 times m2 is equals minus 1. You divide by 4 both sides, you get m2 is minus 1 over 4. So this one is now the gradient of normal gradient. This one was the tangent gradient or curve gradient, because gradient of tangent and curve are the same. Then gradient of the normal, now we have minus 1/4. We now have gradient minus 1/4, that's m, and point we have 1 and 3, that's the point. Then you write y is equals mx plus c, because normal is a straight line. It will be y is equals m is minus 1/4 x plus c. Then use this point to find c. x1, y3. You put 3 here is equals minus 1 over 4. You put 1 where there is x, then plus c. It will be 3 is equals to minus 1/4 plus c, like this. Then it will be 3 plus 1/4 is equals to c. 3 plus 1/4 is 3 and 1/4. That is 3 and 1/4 is equals to c. Then you can substitute it here. So it will be y is equals to minus 1 over 4x plus 3 and 1/4. 3 and 1/4, I can write it as 13 over 4. Like y is equals to minus 1 over 4x plus 4 times 3 is 12 plus 1, 13 over 4. You can multiply everything by 4 to get 4y is equals minus 1x plus 13. Still is the same thing, right? You can just end here. Yeah, it makes sense. Or you can just go further. It depends in the form that they want you to leave your answer. Then next, the normal to the curve y is equals 2x plus 1 over x. At x is equals to 2. Cast the x-axis at a, find the coordinates of a, right? X-axis at a. Along the x-axis, what you have to know that the value of y is equals to 0. That's the x-axis. Along this x-axis, y is equals to 0. So it's a normal to the curve at that point. So it's more like this. If I can draw my x-axis here, then I can draw a normal here. So this one can be a normal, and this one can be my curve. So there's a tangent here. So the tangent means the normal at 90 degrees. So this one is the point A. It casts the point, the x-axis at point A. So obviously y is 0. But what is x? You have to find the coordinates of the point, the value of x. How can we now find the value of x at the x-axis intersection? What you do first is you have to find the equation of the normal. After finding the equation of the normal, then you can substitute, put y 0 to find the corresponding value of x. In that case, you can find the values of a. Just like that. Right. Let's find the equation of the normal first. To find the equation of the normal, you differentiate, you find gradient. To find gradient, first thing, let me rewrite 2x plus, then it's 1 over x. This one x to the power minus 1, let x be on the numerator, so it will be x to the power, you give the power minus 1, applying the laws of indices, right? Applying the laws of indices. Then you find dy dx now. Dy over dx is equals to, then differentiating 2x, you get 2 plus, you bring down minus 1, x to the power minus 1 minus 1. It will be 2 minus, excuse, x to the power minus 2, like this. This one is the same as 2 minus 1 over x squared. I can put it back like this. Then we want the value of the gradient when x equals to 2. The gradient when x equals to 2. So it's saying when x is equals to 2, then dy over dx is equals to 2 minus 1 over 2 squared. 1 over 2 squared, it will be what here? 2 minus a quarter. 2 minus 1 over 4 is 2 minus 1 over 4. Let me just use my calculator. 2 minus 1 over 4 is 1 and 3 quarters, which is 7 over 4. Let me use 7 over 4 in this case. So that's gradient. This one is gradient of a tangent or curve when x is equals to 2. Now I want to find the gradient of the normal. We know that gradient of normal times gradient of tangent is equals to minus 1. That's the basic concept that you have to apply always. So it's 7 over 4. So you say 7 over 4 7 over 4 times m2 is equals to minus 1 to find the gradient of the normal. Then it will be m2 is equals to, you multiply by 4, so it will be minus 4, then you divide by 7, it will be over 7, right? So you multiply by 4, since it's dividing, then you divide by 7, so it will be minus 4 over 7, like this. And take note, this one is the gradient of what? Gradient of the normal. We found it. Now the point is x2, what will be y now when x equals to 2? You have to substitute here, put x2 to find the corresponding value of y at the point where the normal meets the curve. So it will be y is equals to 2 times 2, where there's x you just put 2 over 2. So 2 times 2 is 4, 4 plus half. 4 plus half is 4 and a half. 4 and a half is 9 over 2. Let me put 9 over 2 here, like this. Right, now I have the gradient, I have also my point. You find the equation, y is equals to mx plus c minus 4 over 7x plus c. Now you have to find your c. This one, use these coordinates, 2 and 9 over 2. Where there's 1, you put 9 over 2 here, is equals to minus 4 over 7. Then where there's x, you put 2 here, plus c. Then it will be simplified to 9 over 2 is equals to, then this one minus 8 over 7 plus c. Simplifying this one, what do we get? It's 9 over 2 plus 8 over 7 is equals to c. 9 over 2 plus 8 over 7, what do we get? Plus 8 over 7, you get 79 over 14. So c is 79 over 14, like this. Then you replace your c there. It will be y is equals minus 4 over 7 x plus 79 over 14, like this. So that's how you work with normals. That's how we work with tangents. Then subscribe, like the video. Say Mangeya, signing out. Thank you.